Question? Which one? Let's see. Are you connected to the internet? See, it doesn't seem to be connected. Yeah, you have to accept this. You have to scroll down to the bottom and click accept before you can go to the internet. Yeah.
Sir, for B part 1,
Yeah.
can you just use the formula that we know sine squared plus cos squared that is equal to 1?
I don't have the question open. What are they asking here?
They're asking to integrate tan x and show that it's 1 over cos squared.
Integrate tan x?
Yeah. No, differentiate tan.
Ah, yeah, so you can use tan equals sine over cos, is that?
Yeah,
Yeah.
Yeah, but I'm saying to get the one value, can we just say that cos squared x plus sine squared x is equal to 1?
To get the what value?
The one value. They're saying, they're giving you the answer, but they want the stages.
Yeah, so is the question something like show that the derivative of tan x is 1 over cos squared? Yeah, so you can use the fact that cos squared plus sine squared is 1 in the numerator. Yeah.
How's that 5 grades?
Is it 5 marks?
Yeah, and you can like do it in 2 stages.
Wow, that's generous.
No, that's 3 marks. Yeah, that's 3 marks. Okay. This is for this, 5 is for this. Also, can I see A1? Just see it for a second. Yeah, exactly. I did that. I got a really good number.
Yeah, look at
Minus 1.2. I don't know if it's right or not.
Amna,
Sir?
you working? You sure? Okay.
I did it on the calculator to do it automatically, but sir,
Hmm?
can please come for a second? Or
Which problem?
A part 1.
What? What's wrong with this?
I don't know. I don't know whether my answer is right or
But
wrong.
I'm going to do the answer in a few minutes, so you need to try your best to see if you could do this. Like imagine...
I solved it.
Okay, fine, but write the answer down. No, they want the answer in exact form, not
Yeah, I
decimal.
know.
So you know straight away if you have a decimal, you're wrong.
The issue is the form.
No, you always have dy dx
Always have the
when you differentiate a y term. But it sounds like you need the product rule there.
Yeah.
Yeah.
But when you differentiate y, you get 1.
Yep. Dy dx.
So it's just dy dx.
Yeah. Yeah. Which, when you think deeply about it, the derivative of y should be dy dx.
So it's already
Done?
almost as right.
How are we doing on this question? Are we ready to see it, or are we still working? Give it another minute or two. People wrapping it up, looks like. Mo? Easy peasy, lemon squeezy?
Yeah, I think I missed them in the first question. That's been easy.
Let's have a look. So,
The second part would be I got P is equal to 32.7598 times 10 to the power negative 19. I know. Like I know sometimes I trip up and I get that weird answer because like this is next level.
okay. Are we ready to have a look at it? I can't. Is that yes or no? Which part are you on? No, I think it's time to have a look at it. Let's have a look.
Please.
Right. So,
Is this being recorded?
it's recording now, yeah. Find the equation of L. Exactly. So L is a tangent at the point log 4, 4. So first things first, let's get the m. The m is dy dx. And for this function, it would be, bring down the half. So that's 2e a half x, and then the minus 4 is gone. But we're told what the x is, aren't we? What's the x? Log 4. So this is 2e a half log 4, which is equal to 4. Yeah?
Yeah.
So you have y equals 4x plus c. To get the c, I sub in a point, and the point I sub in is 4 log 4. Y is 4 and x is log 4. So the c, you can see, is 4 minus 4 log 4. So that's our answer for the first part. Y equals 4x plus 4 minus 4 log 4. Part 2. Calculate where this crosses the x-axis. So how do I do that? How do I find out where it crosses the x-axis? Let y equals 0. So I get 0 equals 4x plus 4 minus 4 log 4. So that means 4x equals 4 log 4 minus 4. Yeah? Yeah? Cancel the 4's, and you get x equals log 4 minus 1. Which is right because they say that it should be this in the question. Okay. We'll do 3 now in a second.
Can you please
Yeah.
scroll up a second?
To what part? Part 1? Yeah. I know I must be right because I got this one right, and they tell us in the question that the answer is log 4 minus 1. So, which part? Continue?
Because I did the exact same thing, and I got a completely different
For
answer
what part?
For 1.
What did you get?
I got some crazy number.
Yeah, go on, tell me.
3.267.
For which part?
Part 1 for C.
Yeah, but if you type that in on the calculator, does it match the number you got? And it doesn't?
I think what he typed the exponential into the calculator and then it got that value.
Maybe.
Well, I'll continue, yes? Continue? So, if you look at the picture here, the diagram, how many shapes are there if I want to get the area? Now this is a bit tricky. How many? I'll draw it here, yeah, let's see. So, can you all see you have a curve? You have a curve, and then you have a straight line. And you want this area. So my question is, how many shapes are there? I mean, how many integrations are there? What's the total?
2.
It's 2. Okay, the first one is this shape here, in red. And the second one is in blue here.
Yeah, just
It's not actually, because in between the curve and the line would include this. So what's the first integration? From 0 to what? Yeah,
Log 4 minus
log 4 minus 1. And what do I put inside the integration here? The curve.
Minus the name.
Right, that's the first integration. The second integration is from log 4 minus 1 to where? Come on, what's the upper limit here? Yeah, what number?
Log 4.
Log 4. That's log 4. Now what do I put inside this?
The 9.
The
No.
curve subtracted from the line.
So which is first? What minus what?
The curve.
Curve minus the line, yeah. Because it's in between the two for the blue piece. 4e a half x minus 4 minus, now where's my answer from earlier? There it is. Minus 4x minus 4 plus 4 log 4 dx. So this is, how many marks going for this? Which part? For which part? The whole thing? Oh, that's what Angela was asking me. So you're thinking it should be 0 log 4, yeah? And what would you put inside?
4e.
The curve
Yeah.
minus...
A triangle.
No, just.
It's minus a triangle. It's not.
Ah, I see. Okay, so yeah, that's another way to do it, Amjad. You could do the whole shape and then take away the triangle. That's fine too. Can everybody look up? I just want to be clear, there's two ways to think about this. Curve, line, and you can think of it as first you get the area under the curve, that's under the curve, and then you get the area between the curve and the line. So this is curve, curve minus line. Or, the other way you can think about it, which a couple of people have said, you can think about it like this. You can get the whole area under the curve, and then you can minus, you can cut out this triangle here. You can cut that out, and that will leave you with the piece that you want, which is that bit there. Both are fine. I was doing it this way, but would we prefer to do it this way? I don't care. Yeah, I think it would be quicker. But only if people are happy with doing it this way? Or would you prefer this way? Both? Give me a break, man.
No, just do the first one. Continue on what we're doing. The first one.
The second one, you have to find that. No.
Yeah, it is, isn't it? 'Cause
It's easier.
I think the second way we'll go with is easier then. Okay, let's do it the second way.
No, we looked at first way.
Oh my goodness!
I said the second. I would do the second way, but you should do the first way.
Oh, do the second.
I will take the short path. I would like you to take the long path, please.
Or you could do both.
I could take the short and long path. Amjad, we'll do it that way. Okay? So, if you were to look at this problem now, it's integrate from 0 to log 4. 4e a half x minus 4 dx minus, now we'll have to work out the area of this triangle here. So what's the height of this triangle?
4.
4. Thank you. And what's the base of it?
It's 1.
The base of it?
Yeah, it's 1.
Then 4.
It's going to be log 4 minus log 4 minus 1. Because you know this point and you know this point.
So it's minus.
So it's 1.
Oh yeah, 1.
So what's the area?
2.
2. So that's nice. Actually, Amjad, that's convenient because this triangle worked out so nicely. So we just have to integrate that and do a minus 2 on our answer. Right, let's integrate. So what do you get when you integrate this? You get 4e a half x over a half minus 4x. 0 log 4 go in. Minus 2. And then, what would that be? That would be 8e a half log 4 minus 4 log 4 minus 8 minus 0 minus 2 when you sub them in. So that's 16 minus 4 log 4 minus 10. So I got the answer 6 minus 4 log 4. Okay. Yeah. Can we go on to the next part, B?
So where would the 5 marks go to, if you had to say? Seems like a lot.
I have a feeling they use the other way. That's
Yeah,
in the
I
marks.
think so.
Yeah, what way did they do it in the marking scheme? Let's have a look.
The first.
Obviously.
Well, no, you know that for a fact?
Yeah, I saw.
Yes, I think.
Ah. So that's why you think it's 5 marks.
What would you do in that situation? Would you award them 5 marks?
Yeah. Let me have a look at how I would give the 5 marks here. So, you see the way in the marking scheme they said there's 1 mark for subtracting. So that means that they were giving you 1 mark for having this here. You obviously have 1 mark for the right answer. You'll have 1 mark for the right integration. You'll have 1 mark for putting in the limits, and you'll have 1 mark for setting it up correctly. So that's Mo. That's how I'd say the 5 marks would go. Okay? Next part. Right. Next. What is the derivative of sine over cos? So what rule do I need here? Quotient rule. So that's the bottom squared. The bottom times derivative of the top minus the top times derivative of the bottom. What's cos squared plus sine squared? 1. Okay. 2. Integrate 4 tan x over cos squared x dx, and they tell you u equals tan x. So what does the u dx equal? 1 over cos squared x. So what does dx equal? Cos squared x du. So this is equal to 4 u over cos squared x times cos squared x du. Cancel, cancel. If I integrate 4u, I think I get 2u squared plus c. So the answer is 2 tan squared x plus c. Okay. Next part, part C. Yeah? Part C is we want the derivative. So what type of derivative is this one called when we want the derivative for this? Implicit, yeah. So, minus 6x? Minus 6. And then here we need the product rule. So that's 2xy plus x squared dy dx minus 3y squared dy dx equals 0. So if you rearrange that, you'll get dy dx equals 6 minus 2xy over x squared minus 3y squared. 2. Stationary value. Find y. Yeah, well this, if it's stationary value, this is equal to 0. Now the only way a fraction could be 0 is if the top is 0. Well, what does that make y equal to? Y would equal to 6 over 2x. So y is equal to 3 over x. So B is 3. Okay, that's number 4. That was a little bit tricky in part A, but we're going to have a look at number 5 now, and number 5 looks really straightforward. Really, really straightforward. So give number 5 a go here. Yeah. Yeah. How come you're late? I didn't get a message from anyone. To get your problem sorted? We're doing B5 now in the exam. I've just done B4. come on up, so let's have a look. Is it about B5?
Adding the reds and blues like this be fine?
What do you mean?
Because
Oh,
yeah,
you're saying
I'm
here
just-
you have 2 reds and 2 blues.
No, I'm saying here it's took from the red, here it's took from the blue. I'm just doing it by color only,
Yeah,
and then adding all the reds and all the probabilities.
I don't see a problem with that. You take 2 out, is it?
Yeah. Once each.
Yeah, yeah, that's fine.
Yeah,
That's fine.
instead of doing it each.
Mm.
I'm doing what you got for part B 120. Like 2. No? You said you got? Once you're done. So it doesn't seem enough grades.
We'll have a look at it in a minute.
Can we start doing it?
Got all of it done? People seem to still be working though.
Oh wait. That's the question that.
There we go.
3, like, why is there a statement that the second ball removed is in fact red? What does it mean?
We've seen this before. What does it mean when it says in fact?
Yeah, but why is that statement there? It's not a question.
But it's the information for part 4.
Oh, it's the information part.
Yeah, it's not well formatted because I would have put them in the same sentence.
I thought it was.
Yeah, I understand, Mo, because it almost looks like it's still part of part 3. Are we nearly ready for the next one? I heard you, I'm looking around the class. You know, other people exist in this room, right? Did you you have this one finished? Yeah. We'll have a look at it now. Angela, Aria? No? Let's have a look at this one now. So you have A minus 2. Okay, so we want the mean. How many numbers do we have? How many numbers?
8.
1, 2, 3. So this over 8.
It's there's a 0 here.
Yeah, but you know, plus 0. So what do we get here?
5.
5 exact? Nice. And now the median, I have to put them in order. And how many numbers are there? 8. So it'll be between the 4th and the 5th number. So what's the smallest number? Minus 2? Oh, they're already in order.
Yeah.
Oh, for goodness sake. All right, so it's just 1, 2, 3, 5.5
Yes.
is the median. And lastly, what's the range?
13 minus 2.
Very good. 13 minus 2, which is 15. Okay. Next one is a probability one. A box holds 4 red and 2 blue. 2 balls are removed. Draw the diagram. Okay. So, you can either first take out a red and then a blue, and then a red and a blue and a red and a blue. So, the first one is 4 over 6 and 2 over 6. Then if you took a red out, the next red would be 3 over 5, and this has to be 2 over 5. If you took out a blue, then the next blue would be 1 over 5, and then the other one? 4 over 5.
So does
Yeah.
it matter whether we put it in fraction or decimal?
No.
Because I rounded the decimal.
Why though? Because the fractions are nice fractions. It's fine. It's fine. But I think fractions would have been nicer here, no? Because they're probabilities. Yeah.
Should have been quicker as well.
And quicker too. 2. Hey. Find the probability that at least one of the balls is red. Now there's 2 ways to do this. You can either say it's probability of red. The easiest way to do it is probability of at least 1 red is the same thing as 1 minus the probability of not at least 1 red. Now what's the meaning of not at least 1 red? What's another way of saying that? Yeah, 1 minus the probability of double blue. Yeah? Which is 1 minus 2/6 times 1/5. Which is 28/30ths or 14 over 15. Is that right? Okay.
It's the same as red, red.
Yeah, it's the same as red, 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 blue, blue, red.
I got a completely different answer, like not even close.
Okay, then you did it wrong.
Is it because of the rounding?
No.
The calculation?
No. Part 3. Find the probability that the second ball removed is red. So, isn't it?
No,
Yeah. So the probability that the second one is red. So that's the probability of blue-red plus the probability of red-red, isn't it? Because of an OR. So blue-red is 2/6 times 4/5, and red-red is 4/6 times 3/5. So that's is 2 over 3? Find the probability that the first one is red, given that the second one is blue. That's the probability of getting a red and a blue over the probability that the second one is blue. What's the probability of getting a red and a blue?
I don't think.
No?
The second ball removed is red.
Oh, sorry, thank you. Do I have it backwards?
Yeah.
Yeah, okay, so they said,
I don't think it matters.
we'll see now. Find the probability that the first ball removed is blue, given that the second one is red. So that's the probability of blue followed by red over probability that the second is red. What's the probability of getting a blue and then a red? It's 2/6 times 4/5, isn't it? 8/30. 4/15. Is it 4 over 15 over 2 over 3? Is that right? So, what is it? 2 over 5? Yeah? Okay. Okay. That's all right, isn't it? C. So you have some data, and the first question is find Sx squared, which is sum x squared over n minus sum x over n squared. This formula is in the formula book, by the way. What's the first number here? 159 over 6 minus 27 over 6 squared. Does anyone have that for me? 25 over... What is it? Yeah? Yeah? Okay, and the next thing they want is Sxy, which is sum xy over n minus sum x over n times sum y over n. So that one is 1831 over 6 minus 27 over 6 times 366 over 6. One sec. Say again? 319 over 6. Okay, next part. Find the equation of the line. So you remember the formula is y minus y average equals m times x minus x average. Now I need to get my formula for the m again. Basically the two things they ask you to calculate, huh? So that is 319 over 6 over 25 over 4. So what's that then? y minus average y. Average y is 366 over 6. Oh, 366 over 6 is 61?
Yeah.
Is it?
Yes.
And then the x is 27 over 6, which is,
4.5.
what is it?
4.5.
9 over 2? Okay. Let's clean this up a little bit. Y equals 638 over 75. X plus 61 minus 9 over 2 times 638 over 75. I just need this guy here, please.
I think the SXY is wrong.
I think so as well.
It's 92.
It's not 319 over 6?
Yeah, it's 92 over 3.
That's
Oh.
because I'm not sure though.
It's 92 over 3.
Yeah.
Yeah.
Who gave me 319 over 6? Right, 92 over 3. 92 over 3. So that changes the m, of course, doesn't it? What's the m? Is it a nicer number?
368 over 75.
368 over 75. Okay, so it's still ugly. 368. 368, yeah? So 368. Right, so what's this number now? I'm waiting for just this fraction here, please.
973 over 25.
973 over 25. Can we put these as decimals for the final answer? Y equals 368 over 75, please.
4.91.
And then, what's this?
38.92.
Yeah? That is,
Correct.
yeah, they accept either the decimal or the fraction here. So, yeah, that's more accurate. Okay?
So I didn't expect them to give weird numbers like this.
Yeah,
Sometimes I feel like I did something wrong when I see
yeah.
Because they usually give like nicer.
But for the data question, not always, because they're just, just random numbers. Fine. Okay, well the next one for 2 marks is very straightforward. They just want you to sub x is 2 into this, and what's the y? So if you sub 2 into that formula, what do you get for y? Sorry, I said 2, it's 3. Sub in 3.
54.
54? Exact? Is it 54 exact or rounded?
No, 53.64.
Yeah, just rounded 55.
They accept any answer that is rounded to 54, so that's fine. So what is it exactly though? What was
53.6.
53.6 kilograms? Okay. Lastly, is this answer reliable? What do we think? Sorry, I said kilograms, but it's centimeters. Is this answer reliable or not? What do we think? Do we think this will be accurate for the y or not?
Yeah, it's in the range.
Yeah. We used an x in the set 1 to 8 kilograms. So it is reliable.
Is that what they said in the marking scheme?
Let's see what they said. They said yes, because 3 is in the range of values on which the equation was formed, or similar words. I think B5 was alright. One question left now. B6, if you can try it.
So, but if you look at the way they graded, this is so much work for so little mark.
What do you mean?
Like, I think with the other B questions we worked much less, but we got way more.
No, I think B5 was good.
Maybe it means time-wise on the
Yeah,
calculator.
time-wise. Because you're not counting that we have to type all this up.
I suppose.
And there was a lot of typing up, especially in the first part.
Yeah, but you know, okay.
Yeah.
Some of the calculations. Alright, no, forget it.
Like if you look at B2 or B1,
Okay, fine.
it's so easy.
Fine, whatever you like.
Are we doing B6 now?
Yeah.
So for A number part 2, do you find it for 2 or and 3 days, or is it 3 or less?
A part 2 is fine. It's like asking you two questions. Find the probability that she's late on exactly 2 days or exactly 3 days. Well, oh.
Why didn't they say and?
Maybe because they want to check it.
Or no, it's 2 days, 3 days, and add the answers.
Oh,
Yeah. The or, because they say or.
Should be and.
Yeah, should be.
No, because you can't be late exactly 2 days and exactly 3 days. You can only join those two with the word or. But I think it would have been a bit better for the English if they had said, find the probability that she's late for either
Yeah.
2 or 3 days. That's better. So this is just bad grammar on their part.
But sir, if you're late for 3 days, aren't you automatically late for 2 days already?
Yeah, so I suppose you would have to be say, find the probability that she's late for either exactly 2 or 3 days.
It's either. You don't add the or.
Yeah, add them. This is what we're saying. It's a plus.
Would you be allowed to tell us something like this in the exam? No.
For that
Because this is confusing.
Yeah, very.
grammar stuff, I would. So, like in the exam, I might not tell you to add,
Yeah.
but I might say something like, you could restate the sentence as either, yeah. So the way I feel is I can't give you maths information, but I could certainly feel okay giving you grammar information. My one trusty pencil.
Good have my friends.
Yeah, but I have one. Good old clicky. No, I guess I lost them. I'll borrow one, please.
Sir, will you be giving those papers or
Huh? What? Ah, the courseworks.
Yep.
Courseworks.
Send them today?
Yeah, because again, I have 6 hours and possibly a meeting. Stupid meetings. Just sitting there. Blah, 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 blah. Okay.
Do you actually ever achieve anything without anything?
Depends who you ask. Personally, I would say no. Right.
Oh yeah, have you figured out when the math exam will be?
No. That's your responsibility. Ask your tutor. Who's your tutor? And he doesn't know. He's the guy in charge. If he doesn't know, why would I know?
You're the math teacher.
Yeah,
He
but
said they'll figure it out.
he said he'll figure it out.
Yeah.
And he believes him?
I don't know.
Good point. Yeah, I'm sure he'll check it. Who's beside you, Mohammed? Okay. Amjad. Daniel, who's behind you? I can't see. Oh, okay. Kind of looking like I have. Do I have everybody? Do I actually have everybody? I don't? I think I have everybody, don't I?
I guarantee you figure it
Oh, yeah.
who is
Gafar. I have all minus one. There you go. Are you finished B6? The whole thing? Good man. Get it right.
I think I messed up the B part.
And the A and the C part.
It's easy.
Just 1 or 2 more minutes and then we'll have a look at B6 now.
So for the trials tomorrow, are you gonna do review?
Thought we wanted to do a practice test, wasn't it?
Or
Isn't that the...
for what we took, or just in general?
No, like a real practice test of what it'll be like on Friday.
So including all the
Everything.
will it be multiple choice?
Huh?
Will it be multiple choice?
Oh yeah. Oh yeah. Right, are we ready to have a look at it? Great. B6 now. A student drives to college each day. The times of the journey are assumed to be a normal distribution with mean 54 minutes and standard deviation of 5 minutes. Find the probability the journey will take more than 60 minutes. So we have to do our z equals 60 minus 54 over 5, isn't it? Which is 1.2. And that gives us this area. But is that the area we want? Yeah. But the formula book gives us this area. So it's not 1.2, but instead 1 minus. So what's the answer there? 0.1151 as the final answer. Yeah. During 1 month, the student drives to college on 26 days. 26 days? What college is she going to, and what month is it? 26 days.
He goes 7 days a week except for 2 weeks.
But who does that? Yeah, okay. Right. 2. Find the probability that she's... Huh? Yeah, but... Okay. Or Saturdays. Or Fridays. You don't know her heritage. Okay. 2. Find the probability that she's late on exactly 2 or exactly 3 days. So what type of problem is this now?
2 separate problems.
Yeah, but what formula? Frida? What's it called? Yeah, what? Binomial.
Yes.
Binomial. So, that she's late on 2 days. What would that be? That would be 26C2 2 0.1151 squared, and then 1 minus 0.1151 power 24 plus 3 days 26C3 0.1151 cubed 1 minus 0.1151 power 23. Bash that in on the calculator, and what do you get? 4669. So 0.467. Okay, there's 7 marks for those 2 parts. That's okay. B. Each season, 50% of a crop of carrots develops a disease. A product comes on the market which claims to reduce the risk of developing the disease. The product is applied to a field. At the end of the season, 20 carrots are selected and 6 are found to have developed this disease. Okay, so what's our hypothesis here? Well, the null hypothesis, what is it?
Doesn't have any effect.
Yeah. What way could we say it? We could say that the probability of getting the disease, that's still 50%.
No, it's less than.
No, that's the alternative hypothesis. Yeah, you could, yeah. I'm just stretching it out a bit. Probability of the disease is 50%, even under the new product. So, in other words, I mean, there's many ways you could say it. I just want to show you a different way to say it. You could say the new product has no effect. You could say that half the carrots still develop the disease with or without the new product. In other words, nothing has changed. Okay. Now, a bit more interesting is the alternative. What's the alternative here?
Less than.
Yeah, that the probability is less than 50% using the new product. Okay. Right, part 2. So we have to carry out a one-tail test. We have to calculate our p-value. How many got the disease? 6. So we have to calculate the probability that 6 of them get the disease. Or more extreme. What's more extreme? 5, 4, 3, 2, 1, 0. So in other words, it's the probability that 6 or fewer, which is just simply, you have to use the table book. N is 20, X is 6, and P is 0.5. So what do you get here? 0.057. So that's more than 5%. So the conclusion is do not reject the null hypothesis.
Yes.
So the conclusion is no evidence for an effect.
Sir, can you please check the margin?
For this, which part do you want me to check?
The value. If they plot it, will be good.
5.77%, yeah. Okay. Now, interesting, this is a little bit different, part 3. What would the conclusion be at the 10% level of significance? So 0.0577 is smaller than 10%. So what's the conclusion now?
We reject.
No, we do reject. We reject the null hypothesis. So that's why it's important to say no evidence for an effect at 5% level. And here we reject the null hypothesis at the 10% level.
So it doesn't work at 5 and it works at 10.
Essentially, yeah. Now you might say, well, that seems silly because that's opposite results.
Yeah.
But the standard practice is to use 5%. But you must understand that 5% is just a standard. It's not a rule, you know.
Sir, the
Yeah.
reason I asked you to check the marking from is because I'm not sure whether it's really, it's like, it feels like it's too close.
It's too what?
It's too close to being.
No, it's not. 577. Like, you know, if you gave me €57.70 and I gave it back to you in the form of €50 and I said, wow, it's close.
Yeah.
It's too close actually. You would let me keep 770?
Yeah.
You would.
Yeah.
Do you have 57.70 I could hold for you for a few minutes? No?
I might have.
Just do it a couple of times.
Yeah, just a couple of times, once or twice now. That'd be great. Okay. Now, it says explain your answer. So we better write something here about the difference. We rejected at 10%, but not 5%. All right. What did the marking scheme say? Yeah, that's fine. Okay. Right. C. Can I scroll down? C. Okay. What's the expected value of x? So they tell you the expected value of y is 7. And they tell you that y is 3x minus 2. Yeah. So that means 3 times expected value of x minus 2 equals 7. So the expected value of x is equal to 3 if you solve that. What's the variance of x? Well, they tell you that the variance of y is 145.8. And the variance of y is the variance of 3x minus 2. What's the variance of 3x minus 2? That's 9
Yeah.
variance of x. How did I get the 9? 2 squared, yeah. So the variance of x is 145.8 divided by 9. 16.2. What's the expected value of x squared? Well, you have to remember the formula that says the variance of x is the expected value with the square on the inside and then the square on the outside. So the expected value of x squared is the variance of x plus that guy, which is 16.2 plus, what was our, 9. Yeah,
3.
squared.
Oh,
Ah, squared. 25.2. Ah, that was a lot of work for 3 marks. That's disgraceful. So it would have been 1 mark there, 1 mark there, and 1 mark there. Right. Part 2. Find the value of p. So what would be the key thing to use here? The expected value of x. What was it? 3. So that means the expected value of this table should be 3. So that means minus 3 times 0.3 plus 4 times 0.15 plus 5 times 0.1 plus 6 times 0.4 plus 0.05p should equal 3. So we need to get the p here. Let's see. Minus 0.9 plus 0.6 plus 0.5 plus 2.4 plus 0.05p equals 3. Guys, you're doing that thing where you're not using the calculator and you're just letting me do this myself. P is 8 in the end. Let's see if you're right. You are. Okay.
B5 and B6 were so much more work than others.
Okay, if you think so then.
What did you do?
I would think so. Now let's just have a look here. Just before we finish, can we just look at the next paper? We'll go the next year, version 1. Can you have a look at the next paper? Do you have it open?
Yeah.
Yeah. So quickly, we'll just look at each question, and all I really care about before we started, well, we'll start at the next class, is do we think the question, is there anything unusual in it? So if you look at A1, what do we think? It's fine, it's perpendicular. So A1, if you can just tell me what lessons they're coming from. So A1 is parallel and perpendicular. A2? Complete the square. Guys, my attention keeps getting drawn over here. What? A3. AP. A4. Log equations. A5. Trig equations. So far everything has been semester 1. A6. Yeah, tangent lines. A7, definite integration. A8, yeah, but which lesson? No. Substitution is fine, but it's chain rules. Well, okay. Yeah, substitution. Yeah, substitution. So that's the first question. That's semester 2. A9 by parts. A10, volume. A11, this mean, median, and mode. A12 is the confidence interval. So can you see how much was semester 1? 7 questions. And semester 2? 5 questions?
5.
Yeah? Now, God, please. B1. What have we got? Simultaneous, fine. Inequalities, fine. Remainder theorem, fine. Geometric, and then the binomial expansion. Yeah. B2 looks familiar, doesn't it? Exponential and sine cosine rule. And is there a log in there? Oh, B, yeah. Log quadratic. B3, we've got our, what type of problem is B3A? What lesson is B3A coming from? What do you mean it's not a lesson? No, it's the optimization problems. Remember, it's like a can of beans. And B? No. Partial fractions. B4? Integration. How many integration areas in B4?
1.
No. 2. 0 to 1 and 1 to 2. Yeah? B is substitution and C is implicit. B5. A, what's B5A?
Just like what you just
Yeah, it's scatter plot. The scatter. B is the tray and C is the Venn diagram. And finally B6, A is what type is? Yeah, but which one? Binomial or chi-squared? Binomial. B, normal distribution, and C is the expectation of values. Mo, you had a question?
Yes, sir. For B4.
Yeah, B4.
Line minus curve or curve minus line?
For which part?
The defined.
No. So B4. Guys, I'm just going to wait. So, Mo was B4. Mo was asking, is it line minus curve or what is it basically? So, can we just, last thing we'll do is, can we just say what the integration is? So, there's two areas. The first one is from 0 to 1. And the second one? Amjad. Just look at me. I don't think I'm that bad to look at. Am I? Okay, so you're listening. So what's the area? 0 to 1 and then 1 to 2. Now, first one, first one we integrate what? Line. Not line minus curve, just line. Why? Because it's underneath a straight line. And the second one?
Curve minus line.
No.
line minus curve.
No. Just curve.
What?
It's underneath a curve.
Or we can,
And add them.
or we can just.
Yeah. It's not line minus curve or curve minus line because you're not looking at any area that's trapped between two.
Or we can just use trapezoids.
You could also use trapezoid plus curve if you want as well. Now we'll start section A in the next class of this one. Okay, so we're finished now.